Hi, I'm Rich with insideHPC, and we're here at SC13 in Denver, and we're here at the Altair booth. And we're here today with a couple of guests from NCI. So let's start with you. What do you guys do at NCI? What is your deal?
NCI is Australia's national research high-end computing service. We are funded by the Australian government for the infrastructure, and all of our operational costs are provided by a collaboration of a number of major research organisations: the National Research University, which is our host, the Australian National University, the National Science Agency, which is the CSIRO, the National Geoscience Agency, Geoscience Australia, and the National Meteorological Agency, which is the Australian Bureau of Meteorology. And also a number of the research-intensive universities of Australia are also supported by the major research council. And we are their essentially comprehensive and integrated high-end computing research provider. We span supercomputing, cloud for data-intensive services, and high-performance services, and plus we also have a significant development team that works across the board. We work in areas of priority to the government and also broadly support the research community, and the particular area of priority of the Australian government which led them to invest in it was in climate and earth system science research.
Okay, so something like in the U.S., something like the National Science Foundation, something on a similar kind of bent? Yeah.
A similar bent, yeah.
Okay, so well, let's switch to you. I wrote about the Raijin system. Could you tell me what that system's about and where did that name come from?
Okay, so Raijin is the god of thunder and storms, basically, and a Japanese word in keeping with the theme associated with climate change and climate and weather predictions and those sort of things, which are one of the key research areas that we work on. So Raijin's a Fujitsu primary system, x86, about 3,500 nodes, 57,000 cores. We have 12 petabytes of raw storage behind it as part of the /scratch, which we get 120 gigabits per second in terms of performance, and the machine runs at about 1 petaflop.
So a 1 petaflop machine as a national resource for research?
For research, that's correct.
Okay.
Yeah.
So, well, along those lines, you want to keep that machine busy. How does workload management factor into something like that?
So obviously workload management is very important in terms of scheduling the heterogeneous jobs that we run. The machine's open to all of Australia and all Australian researchers, and so we get a variety of size jobs and requirements, and so having a good scheduler is actually very important to make sure everybody gets a fair share.
Yeah. And how does Altair come into play then? They use the PBS Pro then to do that?
So we use Altair PBS Pro.
Okay.
Previously we actually ran our own homegrown scheduling system, and then with the purchase of Raijin, we decided it was an opportunity to actually look at some commercially supported software, particularly now that we're dealing with something of a much larger scale. So we sort of almost a tenfold increase in what we had before. So the greater complexity, the support aspects were sort of things that drove us to look at a replacement scheduler.
Yeah. So let's kind of wrap up here. What do you hope to accomplish with Raijin? Is there a lot of missions there, or what would you say?
Well, we cover sort of the breadth of research in Australia, everything in the physical sciences, material science, nanotechnology, computational chemistry, a lot of things in the life sciences, engineering, mathematics, but the particular focus is in the environmental areas, some geosciences, earth observation, and principally in climate and earth system science. And what we, I guess, hope to achieve is to increase the performance of the codes that are of significance to particular research communities. And we have a particular collaboration which we have an agreement with Fujitsu, where jointly we, NCI, the Australian Bureau of Meteorology and Fujitsu will be working on the optimisation of Australia's climate modelling suites. And to attempt to pull them up to 5,000 and 10,000 core applications. The biggest job we've had on the machine so far has shown it scales very well. It uses a bit over half the machine at 32,000 cores, but we hope to sort of bring up a number of other ones to, well, not that mark, but push it along a bit.
With a mission like that really hit home, wasn't there a big climate event recently in Australia, some kind of wildfire or something that looked like it's a result of global warming or something?
Well, you're probably not supposed to attribute it to global warming in the politics of our environment, but certainly this climate modelling suite, which is called ACCESS, it's the Australian Community Climate Earth System Simulator. It's a rather remarkable thing. It works across it's the same piece of code that works across multiple timescales. So it does everything between nowcasting, which is 2 and 3 hours ahead, the weather forecasting. Then it will move off into seasonal prediction, then decadal prediction, and ultimately into the climate change, which is the century and millennium timescales. And there are different challenges in optimising it for those different timescales.